Welcome. Let's take a look at the limit as x approaches 0 of 2 tangent of 2x divided by 5x. We want to find the value of this limit and apply L'Hopital's rule appropriately in that process. Recall that L'Hopital's rule can be applied in the case where a limit produces the indeterminate form 0 over 0 or infinity over infinity. So let's go ahead and take a look at this limit. As x approaches 0, 2 tangent of 2x approaches 2 tangent of 0. Tangent of 0 is 0, so my numerator here would be 0, as well as my denominator, 5 times x, would approach 0 as well. So this particular limit produces the indeterminate form of 0 over 0. And this form is appropriate for applying L'Hopital's rule. So let's go ahead and apply L'Hopital's rule. We will write LH over the equal sign to indicate that we are applying L'Hopital's rule. And that is the source of what follows. What follows is the limit as x approaches 0. Now we need to be careful. In L'Hopital's rule, we take the derivative of the numerator and divide that by the derivative of the denominator. We do not apply the quotient rule. This is a different process. So the derivative of the numerator would be 2 times 2 secant squared 2x, where the derivative of tangent is secant squared, and because of the chain rule, we would need to multiply by the derivative of the argument, which is the source of that 2. So that's the derivative of our numerator divided by the derivative of the denominator, which is 5. Now we try to take the limit again. In this case, we will have 4 times the secant squared, and 2 times 0 is 0 over 5. And secant squared is 1, so this is 4 times 1 squared, secant of 0 is 1, so that's 4 times 1 squared divided by 5, which gives us a limit of 4/5. Let's look at a second example. This time let's look at the limit as x approaches 0 of 4x minus 2x, all divided by x. Now, as x goes towards 0, what happens in the numerator? In the numerator, 4x approaches 4 to the 0, which is 1, minus, and then 2x approaches 2 to the 0, which is also 1. So we end up with a 1 minus 1 in the numerator, which is 0. And as x approaches 0, our denominator approaches 0 as well. So we do have an indeterminate form, and our indeterminate form in this case is 0 over 0. So that is an eligible form for L'Hopital's rule. So let's go ahead and apply the rule. This is going to equal, and then we are going to write LH over the equal sign to indicate the application of L'Hopital's rule. The limit as x approaches 0. Now keep in mind that we do not use the quotient rule in this process. L'Hopital's rule is that we take the ratio of the derivative of the numerator over the derivative of the denominator. So the derivative of our numerator, the derivative of 4x is the natural log of 4 times 4 to the x minus, and then the second term, that derivative will be the natural log of 2 times 2 to the x. Recall that the derivative with respect to x of some base to the x power, provided the base is not 0 or 1, is the natural log of b times b to the x. So we're simply applying that rule to the two terms in the numerator. Now the derivative of the denominator is 1. So now let's see what happens when we attempt to take our limit. And we take our limit as x approaches 0, we will have the natural log of 4 times 4 to the 0 minus the natural log of 2 times 2 to the 0 all over 1. And a base to the 0 power, provided the base is not 0, is 1. So 4 to the 0 power is 1 and 2 to the 0 power is 1. So we have the natural log of 4 minus the natural log of 2. And then we can use logarithmic properties to combine those. A difference in logarithms, assuming the same base, is the logarithm of the ratio or the quotient of the two arguments. So natural log of 4 over 2. And we can simplify that to be the natural log of 2. So our limit in this case is the natural log of 2. I hope you find this helpful.